As Nicolas said, I'm also quite new to the field. In fact, I'm not just new, I'm naive to the field, which I think, given the field, is pretty good, because it says that, when I look at the literature, when I listen to talks, I don't have preconceived ideas that I want to just fill with what I'm reading. So I have also, because I'm new, naive, and know little about the entire field, the hard task of convincing you that there are good reasons to, in fact, investigate low-dose IL-2 for treatment of psychiatric disorders and depression. And the reason for which it's pretty hard is because, in fact, I'm not yet a believer. Meaning that I don't think that yet there are enough evidences to really formally link, formally call depression an autoimmune disease until it has proven wrong, to paraphrase Yehuda Schonfeld this morning, or maybe it was his wife who said that, I don't know, he has quoted his wife so often. Anyhow, I think it's a bit early, but in the end I will try to convince you that with what I've read of the literature, with my understanding of the field, I think in fact the kind of a trial that we could propose will actually help address this issue of whether or not there is clearly an immune component that is causative of depression. So to start the talk, I've kind of reviewed some aspect of the literature that I read and tried to use to make my mind around this. So if you think about inflammation and major depressive disorders, you'll find a lot of things in the literature. You'll find papers that will claim that they are linked because stress induces inflammatory responses, but stress also induces depression. Other paper will show you the high prevalence of depression in disease with an inflammatory component, and inflammatory disease, autoimmune disease, metabolic syndrome, etc. are example of this. People, and we've heard this also this morning, have detected increased inflammatory cytokines in the peripheral blood of patients with psychiatric disease. And there are other things like the treatment with drugs that have an anti-inflammatory effect that is associated with symptoms of depression. But all this, I think you agree, are pretty indirect link. When you look for kind of direct link, in fact, I've not found many, if any. Maybe the fact that depression is improved by anti-inflammatory treatment, which is also apparently the scope of the work of the previous speaker, is one of the possibly more direct link between inflammation and the cause of depressive disorders. Now, how would inflammation be involved in the immunopathophysiology of major depressive disorders? There are multiple ways. Again, if you read the literature, you'll find tons of paper. For example, you can actually find in the literature ideas to support the existence of an IL-1 axis that starts with stress, which is a risk factor for MDD that can activate the hypothalamic pituitary adrenal axis, which leads to the release of catecholamine, which then will activate the inflammasome, which will secrete IL-1 beta that will actually go to the brain, etc., etc. So you can find such a good line of thinking, and you can also find in the literature tons of these schemes, and we've seen some during the talks that we had earlier today. And this one actually comes from a very good review paper that was published not so long ago in Nature Reviews Immunology, which is called The Role of Inflammation in Depression from Evolutionary Imperative to Modern Treatment. I'm not going to go through this scheme to try to explain you what I found interesting into it, and there are interesting things, but I will rather just point to one thing that you can find in the abstract of this paper, which to me tells a lot. After explaining the context, the authors claim recent data have elucidated the mechanism. This is a pretty strong sentence, elucidated the mechanism. Of what? By which the innate and adaptive immune system interact with neurotransmitters and neurocircuits to influence the risk. So here, it's not as strong as elucidate the mechanism. And that's a little bit the schizophrenia of the field, where you have a lot of data reporting values of tons of different parameters that have been studied, but causative links that are robust are actually rare. But this is just because the field is new. I'm not criticizing this, of course. So what are my provisional conclusions from this reading? Is that there are several lines of evidences that suggest that inflammatory processes play an important role in major depressive disorder, but it should recognize that these evidences are actually quite indirect. But collectively, they reasonably support putting up the hypothesis, okay? This is a very cautious statement. Reasonably support putting up the hypothesis of a causal relationship between inflammation and major depressive disorders. So for me, that was the start, and actually Marion and Riyad contributed to convince me of all this, and then it actually made me go deeper into this and look at my favorite cells, which are the regulatory T cells, and their role in this disease. So why looking at regulatory T cells when talking about inflammation? Because people think that regulatory T cells, their major role is to control autoimmune diseases. Yes, they do, but Tregs, in fact, they are the checkers of inflammation. They control inflammation. And when you make mice that do not have Tregs, what they have is massive inflammation and autoimmune diseases. In fact, there is an experiment that I like to describe and take the time to describe because I think it's extremely meaningful. It's the one where you take a mouse. You can take a young one, a less young one, an old one, but a normal mouse that has nothing to declare. If you deplete efficiently Tregs in this mouse, you will have in 2 or 3 weeks massive inflammation, multi-organ autoimmune disease, and the mouse will die. And the reason for which this experiment is so important to me is because it tells something that I didn't learn when I learned immunology, and actually Emo revised our immunology teaching his way. Here I'm revising it through the discovery that I made with this experiment that although I was told that we had a thymus that is very good at actually eliminating effector T cells that can actually target self-antigen, this is not the case. We have us normal individuals, no disease, no autoimmune disease. We have in our body tons of effector T cells which can actually attack normal tissues without any additional support or without any additional condition, infection, or whatever. It's just that they don't do it because there are Tregs that are controlling these effector cells. So this has led to this notion that you've probably seen many times of the fact that there is a balance at homeostasis between these effector cells that actually attack normal tissues and the regulatory T cells that control them. And in some circumstances, there is what I call a Treg insufficiency. And this is not a Treg deficiency. You don't need to have deficient Treg, but you have insufficient Treg, maybe because there are not enough, maybe because they actually are not well fed, maybe because the effector cells are too numerous or too active. But if the regulatory T cells cannot control the effector cells, then you have inflammation and autoimmune disease. And the important thing that I want to stress here is that it goes the other way around, if I can say so, meaning that if you have chronic inflammation or autoimmune disease, to me, it means that you have a Treg insufficiency. In other words, if you have inflammation in a depression or in some patients with depression, it means that there is a Treg insufficiency in these patients. Maybe we can discuss this thereafter. So now, having briefly introduced the Tregs, what are the links between Tregs and major depressive disorders? So you can actually find a couple of data in mice. And by the way, I'm not exhaustive in what I've read, of course. I probably missed a lot of a very good paper here. But there are animal models of depression in which there is a Treg decrease. You have actually experiments showing that in vivo Treg depletion prior to exposure to stress led to a higher rate of depressive-like behavior. A rat model of postpartum depression where Tregs are negatively associated with the pro-inflammatory cytokines, and the fact that treatment of mice with antidepressant is associated with an increased percentage of Tregs. And you will agree here, again, that these links are pretty indirect. There is, to me, one experiment that kind of proved a direct link between depression and T cells, not Treg, T cells, which is the fact that by transferring T cells, you can transfer a phenotype. And this experiment is a transfer of T cells from mice exposed to chronic social defeat, but which do not develop the depressive symptoms. And transfer of these cells actually protect the recipient cells. So to me, this is a pretty good experiment. My own bias. In humans, there are also certain types of data that make indirect link between Tregs and MDD, like the fact that adolescents at high risk for mood disorders have a decreased number of Tregs, et cetera, et cetera. You can find many like this. So there are also indirect support for this. Now, what can we do for this? Is it time to go to psychoimmune pharmacotherapy, the modulation of immunity to modulate the mood? My personal view here is that in the absence of robust direct evidences that the immune system plays a causal role in MDD, the constellation of facts that could point to such a role is sufficient to investigate immunotherapy treatment of MDD. I do think so. And in fact, I also think that these therapeutic trials and the accompanying immune investigation that will be performed during the follow-up of this patient will be heuristic to decipher the pathophysiology of MDD. So with this, I suggest, as I'm very simple-minded and I like so much Tregs and not IL-2, I will explain you why, that because there is possibly a link between inflammation and depression, that there is a Treg insufficiency in patients with major depressive disorders. So it's important to stimulate Treg in this patient, and I propose to do so with IL-2. Why IL-2? Because IL-2 is actually the one cytokine that supports the development, the survival, and the function of Tregs. This has been shown now very clearly by many. We were the first to use actually low-dose IL-2 in the treatment of an autoimmune disease. I just will spend just 2 minutes to explain why, because it's relevant to what we're discussing now. We treated patients with an HCV-induced vasculitis. Why did we do so? Because actually with my friend Patrice Kakoub, we investigated Tregs in patients with HCV-induced vasculitis. And we showed many years ago that actually there is a defect in the number of Tregs, here percentages of Tregs in patients with the HCV-induced vasculitis compared to all other control group. But then when we followed this patient, and we of course tried to treat the condition, and there are two ways we can treat the condition. There were two ways you could treat the condition at the time. One is to give the patient another round of antiviral therapy, or to use Rituximab. I don't have the time to explain why. Rituximab is actually killing the B cells. When you give one of these two treatments to a patient, you see exactly the same thing, whatever the treatment you give, which is that those patients that fully respond to the treatment, meaning that they eradicate the disease, they are cured from the disease, recover normal values of Tregs, while those that do not respond or have a partial response do not change their low numbers of Tregs. So what's interesting here is that we actually have this egg or chicken question. Do they recover their Tregs because they're cured, or are they cured because they recover their Treg? How do you solve this question? One way to solve this question is to ask, if I do stimulate Tregs, what am I going to observe? Am I going to help my patient? This is what we discussed. The problem is that at the time when we were discussing this, there was no way to stimulate Tregs that were known. We checked the literature in details. It's a long story. And we figured out that low-dose IL-2 could be a safe Treg stimulator. So we started a trial. We investigated low-dose IL-2 in patients with HCV-induced vasculitis, 10 patients. The dose were at least 10 to 20 times the dose that were used in cancer that were quite toxic. We observed that the treatment was very well tolerated. We stimulated the Tregs, and patient improved. Rapidly, to illustrate this, each time you give IL-2, this is the gray shaded area, 5 days of IL-2, you see an increase in the Tregs, which persists over time. And all the symptoms that this patient have that are colored, this colored bar here, they disappear over time, except for the neuropathy that takes more time to disappear. So this trial actually really opened the door in the therapy of autoimmune disease because it showed that IL-2 was safe at low dose, activate Tregs, does not activate effector cells. And in fact, since then, a lot of experimental data about the mechanism of action of IL-2 on the immune system have been published, which are extremely important for the use we want to do of this drug. First, it's very well known now, and this has been published by many groups in many very good journals, so these are really robust data. IL-2, of course, activates Tregs, I just showed that, but it also blocks the differentiation of the pro-inflammatory Th17 cells, which is good because these are the cells that actually cause inflammation that have also been linked with depression. And it also blocks the generation of T follicular helper cell, which might not be so much needed here. With these extremely good properties for the treatment of autoimmune disease, it's not surprising that low-dose IL-2 has been used in maybe over 30 experimental models of autoimmune disease in mice with excellent results. And this was not just the treatment of autoimmune disease, by the way, it was also a treatment of inflammatory diseases, beryllium-induced lung inflammation, for example, atherosclerosis, which is an inflammatory disease, are very much improved by low-dose IL-2. Allergy also. And of course, I will not have the time to come back to this, but now we're not the only group. There is a lot of competition in the field, and many groups are using this and start to report good results in different diseases. Just rapidly, I want to illustrate that it also works in experimental models of brain disease, like Alzheimer's disease with my friend Nathalie Cartier. We recently showed that when you treat mice that will develop Alzheimer's disease with low-dose IL-2, first you increase Tregs in the blood, but also in the brain of these animals, and that actually will reduce the amyloid pathology in these animals. And in fact, if you do the water maze systems to evaluate the spatial memory, you will rescue spatial memory with low-dose IL-2, as you can see here with this nice cartoon. This is just to mention that it works with brain disease, and if we make the reasonable assumption that depression has something to do with the brain, that could be good. Now, what about the safety of IL-2? I'm running a little late, so I probably don't have the time to go into detail, but it's really not an issue. I just want to stress here that there is one physiological situation in which you need a lot of Tregs, which is pregnancy. And during pregnancy, there is an increase in Tregs and in the activation of Tregs in pregnant women. And in fact, if you monitor these women and check the plasma level of IL-2, you will see that there is an increase in the plasma level of IL-2, which is more or less in the range of what we're doing when we're injecting IL-2 in this patient. So it's pretty safe. It's very unlikely that something that goes up during pregnancy is not safe. We would not be here to talk about it. So maybe I don't have the time to go into these details. We've launched a really large development of IL-2 in different diseases. After the vasculitis trial, we did a dose-finding trial in type 1 diabetes. We treated a child, by the way. The drug can be actually used in children down to 6 years of age. We've been allowed this, which by the way tells you that the agencies are considering that the drug is pretty safe. And we've been doing it in different diseases. I don't have the time to go into the details, and we have 2 phase 2b trials that are running and that will actually provide probably a good answer at whether or not it is efficacious. Now, just rapidly, before I close on depression, we recently looked at the results of a trial where we're treating patients with 1 of 11 autoimmune diseases, and I don't have the time to go through the list. And what we've showed is that the effects are pretty universal, in fact, because across these 11 autoimmune diseases, all patients responded to IL-2 by an increase in Tregs. They all responded to IL-2 by an increase of CD25, which is an activation marker for Tregs. And if you look at clinical efficacy across the 11 diseases, we use the CGI score to do this. And if you look at the disease activity score or the disease severity, they are both improved under IL-2 across 11 very different autoimmune diseases that are affecting different kind of organs. So I think that with this, it's time to go to IL-2, Tregs, and MDD. And I want to go back to this egg or chicken. I told you that I'm not yet a believer, but I think that I can convert easily if I can solve this question of egg or chicken. And in fact, if we induce Treg in this patient and they do better, I will convert with pleasure. And this is what we're going to do. Thanks to EMO, there is this Moodstratification EU grant that has inside clinical trial that we're going to perform with Marion and an Italian colleague that I don't know yet, which is going to be a randomized, double-blind, placebo-controlled, multi-center trial, which will be a proof of concept in using IL-2 for the treatment of autoimmune, of depression. Now with this, I don't have a time to thank all the colleagues that have participated. I'm showing this slide also to tell you that there is a small biotech that is behind some of these trials and that I consult for this biotech. So you can discard maybe all what I said because I'm very biased. And finally, I would pray to give special thanks to, in fact, so first Marion and Rad, because they really, again, dragged me into this very interesting field. Recently, I interacted also with Pierre Lul, who wrote an essay and which really made me look at a lot of the literature. And in the lab, Michel, Encarnita, and Roberta, who was here, have been also important in this development. And of course, Emo, who was kind enough and smart enough to realize the potential of low IL-2 and to put this into his grant. So thank you very much for your attention.